Hello, welcome to the Nature Trail podcast. Here we talk about science, environment, climate change, and the people reshaping our relationship with the natural world. I'm Steve Mokaya, and today's story takes us to a place where technology flows underground and sustainability hums quietly through pipes and sensors. A place where the usual sounds of a city, clanging garbage trucks, dripping taps, overflowing bins, are replaced with something more elegant. We are headed to the Konza Technopolis. You might know it from the glossy brochures or the Silicon Savannah headlines, but today we follow the quiet story beneath its pavements, the way this city manages waste, water, and wilderness, and with the precision of a circuit board and the gentleness of a forest. Let's start with something simple: waste. Most cities pile it, some burn it, others bury it, but Konza does something different. It sends it into the ground, where machines handle what humans' hands used to. We meet Okoth Peter, the person who oversees environment, health, and safety at Konza. He explains the basic principles of this system.
The Sustainable Solid Waste Management Act 2022, it measures on waste segregation at source. So the system that is currently in Konza, that has been installed and is operational, there will be waste segregation into 4 chambers. We have plastics, we have organics, commingled, that is mixed waste, and then we have those papers and all the likes. So once the dustbins are filled up, the system will sense if it is the paper or plastic bin that is full, then it will move, it will be evacuated. It is a vacuum-like system. It will be transported to the compacting base. It's roughly around 14 kilometers. The waste moves underground.
Okay, here's what happens. When smart bins fill up, sensors alert the system. Then with a hiss and hum, waste is sucked through underground vacuum pipes to a hidden compaction center. No trucks, no delays, no smell. To understand the mechanics behind it, I spoke to Francis Mwangi, the engineer steering this quiet revolution.
How this works is a very simple. Consider what you'd do with a vacuum cleaner. On a very small scale, you pick out waste from a vacuum that has been created, creates a low pressure area, of course sucks the waste to a central area, and then from that point you can be able to utilize that waste in different ways. Maybe going on a technical into the technical details of how the system works. We have what we call receptacles, ideally the areas where you put in the waste. We also have, of course, the pipe network that is underground. It's a steel pipe network, 500 millimeters in diameters. As we said, the receptacles are 4 at every one point. The system sucks waste at a speed of 70 kilometers per hour. Which ideally means that within 30 minutes to 1 hour, you're able to collect the waste for the whole of the first phase of the city. Again, this is on the strength of the exhausters or the pumps that we have for creating the vacuum. That ideally means that you can be able to suck this waste at very high speed. So if anything gets stuck into that system, the next batch of waste that is coming in will be able to push this to be able to just get it into this central area. And then again, we have 2 networks in this city. That's the east and the west network. Where we are standing in now, this is the west network. The east network is on the other side, basically here at the solid waste handling facility. The system as set out is from NVAC. That's a Spanish company that has been able to do this. They've been rolling this out in many other areas. This is the first of a kind in Africa that is being undertaken, and we are happy that it is being housed here at Konza Technopolis.
And at the compaction center, swirling cyclones slow down the waste, separating it from air. The air is scrubbed clean and released. The solids are compacted. The result is clean streets and fresh air above and a cleaner system below.
On the one side, of course, we ensure that we have less trucks that are going to be collecting the waste, ideally meaning that we are going to reduce on the carbon dioxide emissions in the city. This building is constructed and with the trucks that are going to be collecting the waste are going to have a carbon saving of more than 89,000 tons of carbon dioxide per year. So what we've done in Konza, all our energy is sustainable. It's green energy that we are using. This power that is coming at Konza Technopolis is from the geothermal power that is generated at Suswa and Naivasha area. So that energy that we are getting is all sustainable. So on all the rooftops of the buildings, we are having solar panels, basically to ensure that we are generating power at source that can be utilized at source, and that has there's no impact on the environment when such power is considered. So for such a facility like this one, we are using fully green energy, so there's no impact on the environment. Again, we have a solar farm that has been set aside at Konza Technopolis for 50,000 acres of land, and this should be able to give us enough power to be able to run these public facilities that might have a negative impact.
By eliminating garbage trucks, the city lowers its carbon emissions, fewer trips, less fuel, and a lot less noise. But Konza's design doesn't stop at collection. It turns waste into something useful.
So once it reaches a certain level of compaction, it will be compacted. Compaction means you will reduce the volume that can be carried. It makes it, that's more of value addition. Then at that level, we have two options. We are in the process of doing waste to energy. That is the same waste that will convert to energy through incineration. We are also thinking of doing organic manure or organic fertilizer. So once the organic dustbin is full, it will be transported to the organic chamber. That's where we'll now cumulatively collect it and use it for composting. We are thinking of introducing black fly soldiers as a means or one of the composting agents. So we'll be doing black fly soldiers at the same time doing organic manure. Because in Konza, we have allocated land for smart agriculture.
Burnable waste becomes energy, organic waste becomes fertilizer, feeding the city's smart gardens, a loop quietly closing. You see, you might wonder, isn't all this expensive? Isn't open dumping cheaper?
Negative impact of open dumping or open dustbin to the environment. Organic waste, the rate of decomposition is very high. Like right now, this, in most cases, you know, the weather here is very hot. It catalyzes the rate of decomposition. That means Konza will not be habitable in terms of bird smell. Two, you expose the waste to scavengers, you know, the birds go to these towns with open dustbins and all that. You'll find that the birds carry the waste, they throw them everywhere. The eyesore, the beauty of the city. You'll never meet waste in Konza at any point. That means you shall have managed the issue of bird smell or littering of the compound.
Cheaper maybe, but cost is no match for the long view. Konza is building a model city, one that is meant to work long after the headlines fade. And the beauty is that thinking extends to water too.
And we have another more comprehensive system that is going to address the sewer ideally as a whole, or what we call the wastewater as a whole. That has already been done in another section of the city. And the process is very simple. It's a biological system that has already been put up in place, ideally utilizing a principle called the moving biobed film reactor, MBBR. And this is basically a breakdown of waste or the sewer that comes into the system at very high rate, because you're introducing oxygen into this system. You are also stirring the waste, basically to ensure that it is a more comprehensive system. We call it a water reclamation facility at Konza Technopolis because it has capacity of reclaiming more than 99% of the water that came into it. All the sewage that came into it, 99% of that water is reclaimable to actual drinking standard. But we're not using it for drinking, just of course to let people know. We have many other non-potable uses in the city. We have firefighting, we have irrigation of the public areas, as you'll be able to see the trees need, of course, to get some water. Yeah. We have other things like what we call dual flushing. You might find that some buildings are providing for two ways of flushing, where you are using either the potable water or, of course, that reclaimed water. So those are some of the uses that we are going to put that reclaimed water from the facility. And again, the solid that comes from it, engineers call it cake. This is used for fertilizer production. So ideally, the only thing we might lose from that is only about just a cubic.
99% of the water used in homes and offices here, bathroom water, kitchen water, is reclaimed. It's cleaned, treated, and reused. Even the sludge left over is turned into fertilizer. organic fertilizer, for that matter. This is the kind of a city where even wastewater gets a second chance. But Konza isn't just focused on pipes and concrete. It is also thinking about trees, animals, and the communities that surround it.
Konza Technopolis is bordered by 3 counties, that is Machakos, Makueni, and Kajiado counties. So we work within the buffer zone, that is 10-kilometer radius. We also work with the communities from the 3 different counties.
So what exactly do you do with the communities?
There are so many activities like tree growing, tree nursery management, and we do have cleanups with the communities, maybe education on rainwater harvesting.
Yeah.
You know, this is an assault, arid and semi-arid areas, so we have to work together.
OCOTH coordinates conservation projects both inside the city and across the 10-kilometer buffer zone around it. That's where Konza works side by side with local communities to plant trees, conserve biodiversity, and restore degraded land. The communities bring something no satellite map can show: experience, stories, an understanding of seasons, animals, and land passed down for generations.
Our key stakeholder as Konza is the community. Apart from NGOs, universities, research institute, KWS, KFS, the key stakeholder is community. Reason, that's where we get our indigenous knowledge system. This is a technopolis. Technology also comes hand in hand with the indigenous knowledge systems. Like you find in our neighborhood, we have community members who can handle bees. These are an area that is highly infested by bees. We coexist with the bees. Even as you move around, you'll find your interaction with bees. But it reaches a time that when they get into the offices, there's a community member who can come and relocate the bees without killing them. There's a community members who relocate these wild animals. Maybe there's a cheetah or such animals within the compound. They come, they relocate them to safer areas.
When wild animals drift from the nearby parks, it's often these neighbors who step in, tracking, relocating, and protecting. Their work anchors Konza's technology in something older and deeply local. Looking ahead, Konza has reserved 1,000 acres for a wildlife conservancy. Once registered with the Kenya Wildlife Service, it will shelter endangered species, birds, big mammals, maybe even the quiet antelope whose hooves don't echo on concrete.
We have 1,000 acres, that's wildlife corridor. We are at advanced stage. I'm working with the KWS office, that is Machakos. We expect that before the end of this financial year, that is before the end of June, we should be in a position to have registered the wildlife corridor so that we have Konza Conservancy where we can do all that matters pertaining to conservation of wildlife.
Are you planning to do some sort of ecotourism from this conservancy? What exactly?
Yeah, we are planning to do that. And then towards the wildlife area, that those animals, specifically birds, which are facing extinction. So we are thinking of having that. Another thing, we are also thinking of having a botanical garden in other areas and a zoo where those animals that we feel are endangered or extinct will be conserved.
And now, let's zoom back into the city. Every building here has earned the green certification. And that's not a checkbox, it is a philosophy. You see, these buildings are built with green concrete, basically a low emission material that looks like another concrete or another block, but this one cuts the carbon load dramatically.
The architect should design the building in a way that the direction of light and all that is considered so that during the daytime we don't consume any form of energy. That is one. During the design, you have to design a building where we use natural ventilation. You look at the direction of wind and all that, that's all considered. We have the green concrete currently being used in Konza. That means this concrete that has been certified that the carbon content is as low as possible. This one is certified at the source. So we have to ascertain the source of the concrete and we look at the carbon content level that is done in the laboratory before we use them. So the carbon, greenhouse emission emanate from carbon containing material. So when we reduce as much as possible the carbon content even of the concrete, that means any form of emissions from that building in terms of the material will be minimized.
Water flows into the Konza from the misty slopes of Mount Kilimanjaro, from the expansive Thwake Dam, and from the boreholes drilled deep into the earth. But in this city, water isn't simply consumed and discarded. It is given a path home. After treatment, reclaimed water is guided into recharge ponds, where it slowly filters through the soil, restoring the aquifers beneath. A quiet return. A cycle complete.
Other than the water reclamation facility that we talked about, we have what we call a water treatment plant, and ideally this handles the potable water or the drinking water of the city. The city has three sources of water. We have water from the boreholes that have been sunk, as I told you, by National Water. So the other things that have been done, of course, to provide water is a pipeline that has been built from Nol to Resh company. This comes from the springs of Mount Kilimanjaro all the way down to Konza Technopolis. The springs of Mount Kilimanjaro are on two sides. We have the Kenyan side and we have the Tanzanian side. We are getting water from the Kenyan side of Mount Kilimanjaro, and this is spring water, ideally clean enough for drinking purposes. So this water gives us about 2,000 cubic meters at the moment, but with capacity of providing us with more than 8,000 to 10,000 cubic meters of water as we are running the city. So the third source of water that will be the eventual supply of water into Konza is from Thwake Dam, the project, the multipurpose dam that's undertaken at the border of Makueni and Kitui. And this should be able to supply water to Konza Technopolis. The volumes that will be supplied from this project are about 66,000 cubic meters of water per day to Konza Technopolis. But the pipeline that has been done is for 100,000 cubic meters per day. And this ensures that the area around Konza Technopolis will also have water that is supplied to it. We are recharging the underground water for the boreholes to just ensure that they have better yields and less, of course, reduce on the concentration of the salts that they have. And this is done from the ponds that we have. The ponds are natural ponds. They also act as recreational parks, similar to what, of course, we have at Uhuru Gardens in Nairobi, but on a smaller scale, just to ensure that people can be able to have those water activities. Again, the ponds are natural in that at their bottom they are not concreted, so it allows for the water to seep back into the underground systems and ensure that the boreholes are charged.
Konza Technopolis doesn't wave banners or shout its innovation from rooftops. Its brilliance is in the systems beneath your feet, in the soft whir of clean technology doing its job. And in a world searching for climate answers, this little city in Kenya may be one of the most important experiments underway. You've been listening to the Nature Trail podcast. I'm Steve Mokaya, and many thanks for your company. Bye.